Alright, number 7. So £360 is shared between 4 people. Now the ratio of the amount that Abby gets to the amount that Ben gets, so the first two, is 2 to 7. So this means that for every 2 parts Abby gets, Ben's going to get 7 parts of it. So way more than Abby. Now Chloe and Danish each get 1.5 times the amount Abby gets. So looking back, we know Abby gets 2 parts. That means 1.5 times 2 is actually 3 parts. So if we have to line this up in terms of Abby, Ben, Chloe, and Danish, we know that Abby gets 2 parts, Ben gets 7 parts, and because Chloe and Danish each get 1.5 times each, 1.5 times 2 we said was 3 parts each. Okay, nice. So now they want us to work out the amount of money that Ben gets. So first things first, we need to firstly work out the total number of parts here. So if we add up all of these parts, we've got 2 plus 7 plus these two, we know that altogether there's 15 parts involved. And we know that all these 15 parts must equal the total amount, which is £360. Now, to work out the amount Ben gets, we need to work out 7 parts. But before that, let's find 1 part, yeah? So 1 part means you're going to divide, 360 by 15. And if you do that, you should get £24 in your calculator. And lastly, to get 7 parts, well, just times your answer by 7. And you end up with £168. And that's it. Alright, number 8. So write this number in standard form. Okay, so to write any number in standard form, all you gotta do is always underline the non-zero values. So in this case, it's 562. Now all you gotta do is just pull that number out and just rewrite as 5.62. So there's always a whole number and the rest as decimal. And then write times 10 to the power something. So this is your common standard form notation, yeah? And now to work out what the power is over here, all you gotta do is literally count how many zeros are before your first number 5, yeah? So in this case, we've got 3. So in this case, it would be 10 to the negative 3, okay? And that's it. This is standard form. For B, we need to now write this as an ordinary number. Well, most of the time, you could probably just drop this in your calculator, and I think you should get the answer. Whereas otherwise, because you've got power 3, all you got to do is literally move this decimal place 3 places to the right. So it will end up becoming 1452. And yeah, that's it. Number 9. The circumference of circle B is 90% of the circumference of circle A. Find the ratio of the areas of circle A to the area of circle B. Alright, so this is kind of a different one. Now, when you deal with circumferences and areas, we don't have to even think about circles here, guys. The whole point of this question is to spot that this is actually a scale factor question. So all it's saying here is that when you're going from, let's say, ratio of B over A, this means that you got some kind of scale factor of 0.9 because of that. However, if you're dealing with areas instead of lengths, then the scale factor is squared, so then it'll be 0.9 squared, which is 0.81. Now, when it's saying find the ratio between the area of circle A to the circle B, we can more or less say that area of circle B is going to be 9% squared or 0.81 of circle A. So in other words, the ratio is therefore going to be 1 to 0.81. And I think it's always best simplified, guys. And what I'll do is just times by 100, and this is basically 100 to 81. So this is the kind of ratios we're looking for. Now for the next bit, it says square E has size of length E centimeters, cool, and square F has size of length F. So it's always good to kind of visualize this here. So you got square E with lengths E, and you also got an F with lengths F, and F. Now it tells us here that the area of square E is 44% greater than the area of square F. Okay, in other words, yeah, if we find the area of square E, so let's call this area of square E. Well, it's just going to be E times E, which is E squared, whereas area square F is just F squared. However, it tells us that the area of square E is 44% greater than square F. So if I have to equate these two, we can basically say that area of square E is literally 1.44. Because remember, when you're increasing things, it's like 100% plus 44%, so 1.44. So it's kind of like a multiplier. So 1.44 of area F, yeah? So that's exactly what they're saying. Now work out the ratio of E to F. So just like the previous question, you see how we went from length to area? We had to square it. We're going from area to length, because remember, this is like areas of the ratio of two lengths, E to F. So since that is, if the scale factor is 1.44, The area scale factor, that means the length scale factor, is going to be the square root of 1.44. And this is going to be 1.2. And that's the answer, guys. The ratio of E to F is going to be 1.2 to 1. So in other words, 12 to 10 if you multiply it by 10. And if you simplify it, actually, like, why not? You get 6 to 5. So I think any of these answers are good. It says that Mary travels to work by train every single day. Now, the probability that her train will be late on any day is 0.15. So this is basically telling us that the probability that her train will be early on any day must be the other way around, 0.85. And remember, guys, all probabilities must always add up to 1. And okay, that's all we're given. So we have to complete the probability tree diagram for Thursday and Friday. Now, from the information, if late is 15%, that means being not late is 85% or 0.85. And well, there's no other condition, so we're just going to assume that it's always the same. It's going to be 0.15 to be late, 0.15, and not late, 0.85, 0.85. So nice and easy, guys. This is an easy 2 marks backed. Now B, work out the probability that her train will be late on at least one of these 2 days. Okay, so this is kind of a clever question. When this is late on at least one of these 2 days, so this means that, for example, you could be late on Thursday and not be late on Friday, or you don't have to be late on Thursday and then be late on Friday. Or, because it says at least, meaning you can also be both. You could be late on both days. So late, Thursday, Friday. So this is essentially, if we look at it this way, we're looking at the probability of being late, so we can write in steps. Probability of being late, which is 0.15 times 0.15, or probability of being not late than late, or late and not late. So it's going to be, in other words, probability of late and not late, and you're doing this twice, yeah? This is just going to essentially be 2 loss of 0.15 times 0.85. And then you just pretty much do the maths here, guys. You just work this out. So for the first one, 0.15 times 0.15, you should get 0.0225. And for the next one, you should get, actually, well, according to my calculator, 0.255. And then if you just add up both results, you should get an answer, well, a total probability of 0.2775. So this is essentially telling us, guys, that there is a chance of being, roughly a 28% chance that she'll be late on at least 1 or 2 days. So that's, actually, I'm not gonna, that's kind of high. That's quite high still. And yeah, that's worth 3 marks. Now, number 11. So the group frequency table gives information about the times in minutes that 80 office workers take to get to work. Okay, 80. So that means the total frequency is 80 so far. Complete the cumulative frequency table. Right, so just a quick recap, guys, yeah? Frequency just means like how many occurred in a certain interval. So for example, according to this data, we can say that on the first part, 5 office workers took about 0 to 20 minutes to get to work, whereas the majority of them, 30 of them, took between 20 and 40 minutes to get to work. So they probably live kind of close. Cumulative frequency just means you just go add as you go along, because you can kind of see that, there's what it's trying to say here, that the first 20 minutes. Now, cumulative frequency table just pretty much tells us that we have to add along, yeah, which is pretty much including or accumulating as we go along. Now, cumulative frequency table is more or less just telling us that we need to accumulate the frequency as we go along. So, for example, if the first row is 5, that means this part is going to be 5. Next part, you add 30 more, so it'll be 35, and so on. And you keep adding. Add 20 more is 55. Add 15, it's going to be 70. Add 8, 78. And add 2 is 80. And this is perfect because it's supposed to check out at 80. Because that's how many, office workers were there. Alright, cool. That's only worth a mark, so yeah. And now on B, we need to draw a cumulative frequency graph for this information. Alright, and this is pretty much plotting the data we just did into this graph. Now to do it nicely, all you guys have to do is just look at the time, just match up here. So for example, we could say that for the first 20 minutes here, so the endpoints, there was a total of 5 office workers. So we go on the 20 minutes and go up to 5. So it's about there. And the next one for 40 minutes, it went up to 35. So 40, shift up to 35, which is there. Next one, 60 went up to 55. And that's like there. So that's it, guys. We just keep doing this. Next one, 80 goes up to 70. 100 goes up to 78. So this is kind of close. You got to be on that line. And lastly, 120 has to be here, right at the top. And as always, for all these kind of cumulative frequency problems, you always start at an initial point of 0, 0. So basically right bottom corner. So this means at no minutes, there should be nobody. Yeah, and now to complete this, all you have to do now is just connect the graph, yeah? So just do a freehand sketch. So start from here and try and do a smooth curve, if possible. Ooh, I missed that already. And just, yeah, it's kind of tricky, but just try your best. And it should end like here. And if you wanted to, you could carry on, I guess, but it's no biggie. Now, for the last part, for part C, it says, use your graph to find an estimate for the percentage of these office workers who take more than 90 minutes to get to work. More than 9 minutes. So what this actually means, guys, is that all we have to do is find the 90-minute mark, which is actually over here, and just pretty much count how many people and then switch to a percentage. So we can say at the 90-minute mark, if we just like literally went all the way up, we're looking to be around here. So this is actually this cutoff point here, or one of these cutoff points. So I'm just going to say, for the sake of, because I think my graph is a bit too high, I think it should cut off around, let's just say 74, yeah? Because I feel like it should be cut a little bit early. So we can say for those who take more than 90 minutes, we're looking at this group, yeah? So this is the group above. And that's pretty much including, what was it, the last 6 people? Yeah, so 80 take away 74 is 6. And to change this to a percentage, guys, that's essentially 6 over 80. And you just multiply that by 100. And if you do that, you should get about 7.5%. And that's your answer, guys. That's it. I just want to thank you guys for coming to this end of my channel, and if you've enjoyed the content so far, just go onto my channel page, hit the subscribe button and hit the bell for more notifications, and if you want, you can do personalized or all, and that way you won't miss any future maths or educational videos. Anyway guys, thank you for watching and see you next time. Ciao.